Hello and welcome everyone to Know Your Scientist series presented by Kshama Ahmedabad Academy of Sciences. We today have with us Dr. Anil Bhardwaj, who is the Director of PRL. We welcome you, sir.
Thank you.
So we usually start with this introduction about our guests, what and how the achievements they are. But when I started going through your social media profiles and LinkedIn, I found out it is a lot of achievements and so much of medals that it would take a really long time to intro it by myself. So I would just request you to how should we address you? How should we give an introduction to Dr. Anil Bhardwaj? How would you address yourself, sir?
I will call myself as a planetary space scientist.
Okay.
Working in the field for last 4 decades or so.
Great. Perfect, sir. So that is our introduction, and we would just start with your early life, sir. So my first question goes how would you describe your 12-year-old self?
For 12-year-old?
Yes,
now I have to start going back to my childhood.
Yeah.
Around that time, I was in my 9th grade kind of thing, and I was studying in a school in Lucknow called Mahanagar Boys. So that was one of the very good schools in Lucknow at that point of time. I'm talking about 80s, and it was a school which I started attending from 6th grade. And that time the school was only up to the 10th grade. And after that, I went to a college which is called Lucknow Christian College, where I did my plus 2, and that was with physics, chemistry and maths as the primary subjects. And so the days were quite good. We used to enjoy a lot. We used to play cricket quite often.
Okay.
And that was my favorite sports. Of course, I used to play football, I used to play volleyball and other sports, but of course cricket was the most favorite subject, and we used to listen to commentaries that time because there was no much TVs and other things at that point of time, and therefore we were quite engaged by listening to commentaries of sports players.
So what were these your natural inclination, domains of your natural inclination back then?
When I was in my 12th year, that is plus 2, I was inclined towards electronics.
Okay.
And my idea was to learn how to make a transistor. Transistor means like a radio,
Okay.
How do you make a radio set? Right. Which we used to call transistor that time, not the actual transistor,
okay, not this
which is PNP, thing. Not the PNP wala.
The RC.
It's basically a full-fledged system where you can tune to listen to any channels, of the channels.
Okay.
That is called medium waves that time and short waves. And so that actually decided some kind of fate for me that I should learn more physics to know how things are happening, what are the new avenues in those areas at that point of time, and that led me to not go for engineering but to go for basic sciences.
Great. Okay. The next question goes how do you describe your parents' contribution towards this journey of yours? As we know, for every child, their parents literally pave their way in a very emotional way, or they imbibe the qualities as a child. As we can see that you have really great qualities in you. So how would you describe your parents' contribution?
Oh, they were quite at ease with me what I wish to do in my life. Luckily, in our family, I am the youngest son among the 3, and my 2 elder brothers are both doctors, medical doctors. So I don't wanted to go into that medical regime, and I was more interested to do science and physics or learning more technology aspects. And therefore, I choose physics in my BSc as well as for MSc. And as I told, I was more inclined towards learning electronics and basic core physics subjects. So I chose to do that, and there was no pressure on me to say, no, you should do engineering or you should do that. They were all very happy that whatever I choose, I should do the best.
Great. So by that time, in around 80s or 90s,
80s.
when this was
80s.
really a conventional thing to either go for engineering or doctor, this
Yes,
was the
yes,
freedom that
yes.
you got. Great. How was science back at that time, as in a field and as advancements?
Science was doing quite well, and but only thing is, yes, as you also mentioned, that people used to think, are you going to become an engineer or you are going to become a doctor?
Right.
And nobody used to talk about other fields that time.
Okay.
But of course, things have changed now. There are many more opportunities available to students who want to build a career in other areas,
Yes.
other than these two core fields of doctorate
Right.
or engineering. And things were progressing pretty well in terms of science, and it all depend upon how you look at it. So I look at from my own perspective of how and why I should do it, and therefore I started pursuing it.
Okay. Would you like to mention any of your mentors back in this journey of your whole educational background, or someone that would have helped you really, that a significant turn in your life?
Around when I was doing my MSc in 1985, 86, 87 time frame,
Okay.
there are two major events which are happening. One was the return of comet Halley,
Okay.
which has a 75-year period, and it came back in 1985. Second thing was the Voyager mission, which was launched by NASA to probe Jupiter, Saturn, Uranus, and Neptune, was having a flyby of Uranus around 86.
Okay.
And that caught my attention, that these are two very major events in one's lifetime, because 75 years of periodicity of a comet Halley means you will have it once in your life.
Right.
And then suddenly it struck to me that why this kind of processes are happening, what we know about the solar system, what we know about these comets, and that made me more curious. And that's how, after my MSc, I started doing research in these areas of the solar system science.
Okay.
And I started working on outer planets and comets.
Okay.
So my PhD is actually on outer planets and comets.
Okay, sir. Great. So, except from this mainstream science and planetary research, do you have any hobbies to unwind and get?
That kept on changing as I grew.
Okay.
So earlier I was telling you I was quite playing cricket and other sports that started reducing as you get involved into research and you have to spend a lot of time in doing research.
Yeah.
So the hobbies started changing as more electronic gadgets started coming. TV came around late 80s and 90s, and we started watching TV in sports channels, and we had the India winning the World Cup and things like that. And slowly these hobbies changed into learning more in science. So it became a part of my hobby to read magazines, science magazines, as well as books. And then it started moving towards understanding better what is happening in other areas, not just in my area of space science and solar system science and things like that, or planetary science, but what is happening in other areas in science. How is the medical field growing? How is the chemistry growing? How is biology growing? And what is the interlink between the two? Because as I started my career as a scientist, as a research scholar, and then grew up, I found that there is no what you called boundaries between different disciplines like physics, chemistry, maths, biology and things like that. At higher levels they all intermix.
Right.
And that was a requirement, because if you have to grow, you have to actually work at inter-exchange of different fields, and to understand one you have to read the other.
Right.
And therefore my hobbies started becoming reading more and understanding better the other areas, so that I can do better in my own areas.
Great. So So based on how you explained about your childhood and your hobbies, I feel that you were one of a kind. Like you would be a rare kind of student back in your time. Was it a thing, sir?
I was more or less like an ordinary student, I should say. Of course, but I used to have a knack of doing things slightly differently. I used to not just read but also try to understand things as I can at that point of time. And we always see back and say, oh, I should have done it much better at that point of time. But of course, it was quite okay for me at that point of time. But as you grow, you become more and more knowledgeable. And as you become more and more knowledgeable, you understand that you understand very little. And therefore, one has to be a student all through the life.
Right.
And that is the one which I have now realized fully.
Okay, great one, sir. Next question goes towards the field of arts. Do you feel that there is some significance of arts, as you just said that all fields are at the greater levels above connected with each other? So do you feel that there is some significance of arts, like if you pursue it, it helps somewhere else in our scientific aptitude? What would you take?
Of course, yes. I should say music is one thing which I used to enjoy in my childhood. I used to listen to old songs. Now old songs. That point of time they were all young songs of that time.
Right.
And those were the songs which were eternal. And any point of time, even now when I hear, it gives a pleasure to me.
Do you listen to them now also?
Yeah, I listen to them.
So
music
what's your
now
favorite
also.
song, sir?
I can't recollect one of them, but I should say that yes, Mohammad Rafi, Lata Mangeshkar, Mukesh are quite singers whose songs I love. Even Asha Bhosle, for example. And there are many others. Even I like ghazals.
Gotcha.
So I listen to many of the ghazals singing by old, very good singers or ghazal singers. And they continue to do that now also for me. I get peace by listening to them.
Right. So as you just said that you have really a well-attended personal life as well as your professional life. So how do you balance both of these aspects in such a nice manner?
Of course, you have to do that, both personal life, professional life, family life, social life. It's a part of the human work.
Right.
One has to devote certain amount of time for each of the activities. But you have to keep in mind that, what you want to achieve in the and if you keep that as one of the goals, rest all will keep following you. And therefore, you have to be a social. You have to be socializing with friends, with your professional colleagues, with your peers and superiors, as well as your juniors. And you have to also keep in mind that you have to mentor juniors, which is also a very, very important aspect. And for that to do, you need not go always as a professional way of doing it. You can make it more as a social way of doing it. So these are the things which keeps on changing as you grow up.
Perfect. So any moments from your childhood or from your college days that would you like to share with us? Like some,
Okay, so we used to get a lot of joy when we used to win cricket matches.
Okay.
And later on, as I grew, I used to enjoy meeting any great scientist. So I still remember when I was in Lucknow University doing my MSc, there was a visitor from US who came to visit Lucknow University and gave a lecture there. And we are all going around in the Lucknow University campus with him. And during that walking through the campus, we were just discussing with him. That gave me some kind of motivation of how a scientist is and what kind of thought process the scientist has. And that helps me understand that there are ways in which you can build up your own career by looking at what is happening and what can happen. And that was more of a personal experience to me, but of course it also reminds me that there is much more to be done in science, and that also helped me shape my career.
Great. So sir, as you mentioned your MSc from certain universities, if we just follow your educational background and the line, what happened after which, from the +2 towards where you are today. So what were your achievements in especially educational field?
Okay, so as I mentioned that I did my +2 from Lucknow Christian College. Then I did my BSc from Lucknow University as well as MSc from Lucknow University. And after that I moved to BHU, Banaras Hindu University, and I joined IIT BHU for doing my research. And as I mentioned that I was fascinated by solar system science and comets and outer planets, I chose to do research in that area. And therefore my PhD was on study of aurora and air glow on outer planets and comets.
Okay.
And that was about 5 years of my work for my PhDs. And very soon after I was completing my PhD, I got an offer for research position as scientist SD in Vikram Sarabhai Space Center in Trivandrum, which is one of the biggest center of ISRO. And then I had offers of postdoctoral work in US and Canada, but then I thought it is better for me to get a permanent position because that was very difficult at that point of time. And then I joined ISRO at Vikram Sarabhai Space Center in Trivandrum, and I joined the Space Physics Laboratory that time.
Okay, so how did PRL happen?
So my career started from a Space Physics Laboratory, and they were looking for a young scientist who can start the planetary science program there.
Okay.
Because they had a program in atmospheric science and space science there, but nobody was working in planetary science. So I joined there in 1993, and I started working in the area of planetary sciences. So I started growing this field. So I started guiding students there in these areas. And by the end of last millennium, or you can say the beginning of new millennium, we were in a position to talk about planetary exploration program in the country. And that was the time when ISRO was talking about whether we should go to moon. And that was the time the Chandrayaan 1 discussion was going on. And I said I would be very keen to participate in that. And I proposed an instrument which is called SARA, which stands for Sub-kV Atom Reflecting Analyzer, which was an instrument of its own because none of such instrument has ever been flown to study the moon. And this was a joint collaboration between India, Sweden, Japan and Switzerland. And I was the one who was leading from India from Vikram Sarabhai Space Center on that. And that experiment was selected, and that's how my journey into space exploration started.
So could you consider this as a turning point in your life about leading India's Chandrayaan 1 mission, starting your pioneering career like this?
Yeah, of course, it was a real turning point for me. But I should also add here that before that I was working in NASA Marshall Space Flight Center for 2 years.
Okay.
So I went there as a NRC Senior Research Associate. And that was actually in the area of looking at planetary X-ray emissions.
Okay.
And that was using the Chandra X-ray Observatory, XMM Newton, which is an observatory of ESA, European Space Agency.
Okay.
And while working on them, I actually discovered X-ray emissions from Saturn rings. I also discovered X-ray flares on Jupiter and Saturn. And they were also very important contributions with respect to how these two giant planets behave and what are the processes which contributes to formation of X-ray emissions from these planets. But when I returned back to India, I was fully dedicated to Indian Planetary Acquisition Program, and I started working on the Chandrayaan 1 mission on the instrument called SARA, which we had the launch on 22nd of October 2008. The Chandrayaan 1 mission.
So, right, we were just kids around that time. We didn't even know what Chandrayaan 1 would be. What would you consider your top 3 contributions towards, let's say, PRL India or let's say world with your research projects?
One of them, which was from the SARA experiment on the Chandrayaan 1 mission, is to know that the solar wind, which is coming from sun all the time, 24/7, which consists of largely protons with a velocity of about 400 km per second coming and hitting the moon, which doesn't have a substantial atmosphere, comes and hits and get absorbed. That was our understanding prior to the Chandrayaan 1. But this understanding totally got changed because we showed using this instrument that a significant part of the impacting solar wind protons gets converted to neutral hydrogen and gets reflected back from the lunar surface. And that was a big understanding change of the lunar science, that the impacting solar wind protons are not completely absorbed. We also showed that these protons which are coming from the solar wind are coming and hitting the night side of the moon, which was totally an unexpected result, because nobody was expecting these protons from the solar wind to turn around and hit the night side of the moon.
Right.
And there were many others significant science results which came out, which changed our total understanding about the moon.
Okay.
And this was all happening around 2008, 9, 10 time frame, when we had observations from the SARA experiment of the Chandrayaan 1 mission.
So during these researches where many newer kind of happenings are coming, or when you're getting results that you didn't expect, what were your key challenges and how did you overcome them for such new results? Like it's almost that you are discovering new things and you're leading towards new knowledge. We can say that we are getting new things to know. So we are not, obviously we're not going to be equipped with enough of apparatus to handle that data, or let's say the situation. So what were certain challenges that you overcame?
Of course, you have to understand the observations, you have to understand the data which has come to the ground, and then bring out science. But more than that, I will tell you that challenges started coming when you started building the instruments.
Okay.
I will tell you about the Mangalyaan, that is the Mars orbiter mission, where I was leading an instrument called MENCA, which stands for Mars Exospheric Neutral Composition Analyzer. And this mission was conceived on a very short time scales, and we had to develop this whole instrument within 2 years.
Okay.
And generally, otherwise, the development instrument cycle is about 4 to 5 years time frame. And that was particularly because if we don't go in a given time frame, we will be able to go after 2 years, which is depending upon the position of the Mars, Earth and the Sun,
Yes.
because both Mars and Earth are going around the Sun. So the most optimal way from Earth to Mars comes after about 2 years.
Okay.
And we were given about 18 to 20 months to get ready to fly a mission where my instrument was selected. And that was a real hectic time for me. I was almost working like 16 to 18 hours in the lab. We used to go early morning and return middle of the night, and then early morning back to
For
the
2
lab.
years?
For almost 1 year, I should say. 1.5 years. And of course, it was quite tedious, quite tiring, but of course quite enjoyable, because we are developing an instrument to fly on the first Mars orbital mission of India.
Right.
So that joy was there, but of course there was a lot of tension,
Right.
lot of issues to be resolved within time frame, so that my instrument can go on board the spacecraft and fly.
Okay.
And the joy comes when the first data came from this mission.
Right.
After 10 months of travel from Earth to Mars, we got inserted into an orbit around the Mars, and we saw the first data coming.
How would you describe that moment?
Oh, that was a wow moment for me, because we are seeing the data for the first time, which is really, really fascinating for all of us who worked for spending so much of time to get this kind of observations.
Right. What would you like to say about the latest advancements in planetary and research field that you are?
Oh, you must have heard about Chandrayaan 3 mission,
Of course.
where India made history by landing the Vikram lander into the southern polar region of the moon.
Yes.
And India became the first country in the world to land in the near the south pole of the moon. And I can show you, we have this model over here of the Chandrayaan 3, where the top portion is actually the lander,
Yes.
and the bottom portion is the propulsion module, and they were all going from Earth to the moon as a composite. And after we reach the desired orbit, this lander got separated from the propulsion module, and this is what actually landed into the southern polar region. Let me put this back here. So we landed into the southern polar region around 70 degrees south, and after that, if you see over here, we had this ramp which was opened, and you will see this rover which was sitting inside,
Right.
and that rolled out.
Okay.
And we had, V means PRL has an instrument right in the front of this, which is called APXS, which has to work. So we are all very anxiously waiting after the successful landing that the rover has to roll out and start doing science.
Right.
And it worked for about 12 days on the surface of the moon. If you want to look at it in more detail, I will show you this one.
Okay.
So this is a model of the rover which moved onto lunar surface,
Yes.
and we had an instrument here right in the front which collected data for the first time about the elemental composition at high latitudes. And this is the first of its kind of observations, which is now published in the international journal called Nature, which is the highest impact factor journal
Yes.
in the world.
So, sir, PRL does come under this space, and research organization of India. So, many of our viewers might not know about PRL's contribution towards the space exploration and this instruments. Like you just said, that PRL had this instrument made up of. So, what other contributions does PRL have for space and planetary research?
Okay, let me just tell you a little bit about PRL.
Yeah.
So PRL is the first institute for space research established by Dr. Vikram Sarabhai in the year 1947. That is the year when India became independent. And Dr. Sarabhai has a dream that India should have a space program, and that should be used for the benefit of the humanity or for the social benefit of the countrymen. And therefore he established this institute in 1947, and all the program related to space research and space science started from this very lab. And you see whether it is a satellite program, it's a rocketry program, it's an application program, all started from this very lab. And later on in 1969 only, the ISRO was established.
Okay.
So PRL is a mother of ISRO actually.
Okay.
Okay.
Right.
And later on, after a demise of, or I should say sudden demise of Dr. Sarabhai in 1971, in 1972 government formed the Department of Space, and that's how the PRL came under Department of Space. In the early part of the exploration, the focus was to do the benefit to the humanity and to the countrymen. And therefore the programs were on application, communication, navigation, disaster management and things like that. But in the new millennium, as India progressed, we started talking about exploration of different planets in our solar system, like Moon, Mars and things like that. And that's how the activity of exploration started, with again PRL taking the lead, and the Chandrayaan 1, this was scientist was actually the former director of PRL, Professor J.N. Goswami, who was leading that time as the director of PRL. And subsequently, PRL contributed to Chandrayaan 2, more recently Chandrayaan 3. We have instruments currently flying on the Aditya L1. We have instruments currently flying on the Chandrayaan 2 orbiter, which is still in orbit around the moon, and sending us high quality data. So PRL has been contributing to space and planetary exploration program in a very big way.
Okay. So, sir, how was your journey of joining PRL to becoming the director?
Oh, I actually joined here as a director of PRL.
Okay.
As I mentioned to you earlier that I was working at Vikram Sarabhai Space Center. I joined there in 1993, and I was actually the director of Space Laboratory there in early part of 2010 to 2017 time frame.
Okay.
And so I was leading the Space Laboratory from 2014 to 2017 before moving to PRL in 2017. So I have been here now for about 8 years,
Great.
leading as this institute, this great institute established by Dr. Sarabhai. So it's actually a wonderful feeling
Yes.
to lead an institute which is established by Dr. Sarabhai.
Right. Any initiatives we would like to mention that you're proud of right now about PRL, initiatives of PRL?
PRL has been working in various domains in addition to space and planetary sciences. For example, PRL works in the area of quantum communication.
Okay.
PRL has been working in the area of astrophysics and more particularly in the area of exoplanets. PRL is the first institute in India who has discovered exoplanets from India using our own instrument and using our own telescopes at Mount Abu in 2008. PRL is working in cutting edge research in femtoseconds, in high energy physics. So in addition to these areas, we have been working very well in the area of space sciences and atmospheric science. PRL make observations of various gases in the atmosphere, look at profiling the different layers of the atmosphere. We have a network of LiDARs across country where we make observations to understand the changes which happens at different levels of the atmosphere, and the cloud properties, the cloud coverage and things like that. We also work in the area of geosciences where we look at various processes which is happening in the solid earth, in the area of ocean atmosphere coupling, biogeosciences, and we also look at meteorites which falls on planet Earth and try to infer are they linked to any planet and what properties about the solar system or early solar system we can know using the analysis of them in the labs. So we have a huge variety of the labs for different activities, whether it is geosciences, atmospheric sciences, space sciences. We also have a observatory in Mount Abu, as I just mentioned. We discovered exoplanets. So currently we have 4 telescopes. We have 2.5 meter, 1.2 meter, 53 centimeter and 43 centimeter. And then we have an observatory in Udaipur, which is called Udaipur Solar Observatory, where we have a telescope to look at the sun, which is 50 centimeter solar telescope, which is the biggest solar telescope in India. So PRL research is multifaceted in different domains, but our focus is to understand fundamentals and fundamental physics, processes, and how the things are happening. And we use that to enrich the science globally.
Okay. So what would be your view on science and how it is dealing with current challenges that world has on a global level about the climate change or sustainable development? What is the role of science in dealing with those challenges and what's your view on it?
Climate change is of course inevitable, and we have to deal with it because humans are making a lot of contribution into that.
Yes.
And we have to understand that if we disturb the nature will react in different ways. And that is why we are seeing this kind of impact which is happening worldwide, including of course in India. Energy is a requirement for humans because we need energy for many activities, development activities and things like that. So how do you synergize this? Both not to disturb the climate, to have the sustainability and to fulfill the requirement of energy, which is primary requirement for any development activities. We had to look at how do you sustain this, sustain without disturbing much the nature. And that is why the work of sustainability is coming to picture, that we make more and more reusable of the things rather than using it once. And these are the areas in which a lot of research is being carried out, but More importantly, if you do fundamental research, there may be some solutions to this. And that's why the aim of PRL is more into doing fundamental research so that we find solutions to sustainability.
Okay. Sir, about for young researchers or young students like us who are wanting to pursue careers in this field, what would you mention certain qualities which could be really helpful? How would you guide us?
See, for research, two things are very important. One is hard work, and second is patience. If you have patience, you can continue to do research. Otherwise, you will feel like fatigue and you will lose out.
Okay.
So, patience is a very, very fundamental requirement for a researcher. Sometimes, while you are working on a problem, you will see the results are not coming. You are not moving further. You are almost like stagnant. And that is a time when your patience or perseverance actually matters. So you need not have to lose hope. You have to continue. Some solution will come out, but it will sometimes take time. And therefore, hard work is also very important. These are the two primary qualities. And of course, the third one is your own motivation, dedication, which is required in research. Because if you don't have dedication, you don't have motivation to continue, it will create issues for you. So for any researcher who she or he is interested to work on, they should choose what they feel best, but then continue to work. So that is some basic requirement for research.
Got it, sir. Thank you, and we can move to this conclusion. What would you like to give a concluding speech to our viewers, students, and many researchers right now would be watching after this video? So what would be your concluding message to all of them?
I would say we all are researchers in our life.
Right.
In whatever way we do, we try to do things in our own way, more innovative way, and that is a part of the research. Only thing is, yes, you are not writing a paper, you are not publishing a paper, and that's all. But each and every one of us are actually a researcher. Only thing is, when we say a scientist, they are working on a particular domain, particular field, particular subject, particular area, and then they find something new and they write papers. But continue to become a researcher, continue to be a student throughout your life, and you can learn much more than you are thinking right now. So good luck to all of you who are watching me. Thank you.
Thank you very much, sir. We are really delighted to have you today.
Thank you. It was a pleasure talking to you. Thank you.